everyone, and I wish you a very good afternoon. So, as you all know, we always begin with a short self introduction. So, today I, Tejaswini Gurung of Electronics 6th semester studying in Rajiv Gandhi Government Engineering College, is here to present a small presentation on AM transmission. Many of you would be aware of it, many of you won't be. So, this presentation will surely help you for a very better and clear understanding on this topic. So let us begin. Here you can see on your screen are listed some content which we are going to discuss further in this video. The first one, as you can see, is related to the SSB generation. So in this video we are focusing about single sideband generation. But before beginning to the main topic, we should know what is AM, because basic is very necessary for any further kind of knowledge. Now here we can see what is AM. AM is amplitude modulation. Like when we hear amplitude modulation, it means modulation on the basis of amplitude. Now we consider two types of signals, which is a carrier signal and a modulating signal. Modulating signal is also known as a message signal, which has to be transmitted, which contains all the required data. So in amplitude modulation, the proportionality with respect to amplitude is taken in reference. Now moving further, here we can see three types of signals, which is a message signal, a carrier signal, and an amplitude modulated signal. The amplitude modulated signal is the final signal which we receive after amplitude modulation, which has to be transmitted or which is being transmitted. Here on, moving forward, we find there are three types of amplitude modulated signals, which is DSB-FC, which stands for double sideband full carrier, DSB-SC, which means double sideband suppressed carrier, and at last SSB, which means single sideband, which is obviously having a suppressed carrier. While DSB-FC is the most basic signal which we receive after an AM, but later on we discovered that it is not very efficient and consumes much power. But the DSB-SC, means suppressed carrier, is 100% efficient and consumes less power, which makes it more advantageous than DSB-FC. While after that SSB came into existence, means that it uses the power and the bandwidth in a very efficient way, which is more useful than both of them. Then here we see the generation of SSB. We all know SSB means single sideband. Single sideband, as we know, there are two sidebands, which is upper sideband and lower sideband. Later on we discovered that both the sidebands are the mirror images of each other. Therefore, we can reduce one of them, either the upper sideband, which is USB, or the LSB, which is the lower sideband, to reduce the power consumption and increase the efficiency. Then we find out that there are three methods of SSB generation. Number one is the filter method, number two is the phase shift method, and at third we have the third method. Let's see what does the first method shows. Here, as you can see in the diagram, that's a block diagram of filter method, we see that there is a product modulator which modulates the message signal, which is the modulating signal, with the carrier signal. After moving forward through the product modulator, we find that we receive a signal which is DSB-SC, means double sideband suppressed carrier signal. But after passing it through a band pass filter, we get a SSB modulated signal, means single sideband. The double sideband get reduced to a single sideband. That is, either we get a upper sideband or a lower sideband, which depends on how the band pass filter is.
So, as discussed earlier, these were the 3 points which are mentioned. Now, moving further, we see how to design a bandpass filter. A bandpass filter should occupy the same frequency range that is occupied by the spectrum of the desired SSB modulated wave. मतलब जो हमको desired modulated wave चाहिए SSB का, उसका जो frequency range का spectrum जो है वो same होना चाहिए जो bandpass filter हमें बनाना है, मतलब उन दोनों का. एंड द सेकेंड इज जो हमारा जो गार्ड बैंड है जो सेपरेट करता है द स्टॉप बैंड एंड द पास बैंड को, तो उसकी जो फ्रीक्वेंसी है वो ट्वाइस होनी चाहिए द ऑफ द लोएस्ट फ्रीक्वेंसी ऑफ द कंपोनेंट ऑफ द मैसेज सिग्नल. बस ये दो क्राइटेरिया है डिज़ाइन करने का बैंड पास फिल्टर. अब हमारा आता है सेकेंड मेथड इज फेज शिफ्ट मेथड. तो जैसे कि हम नोटिस कर पा रहे हैं दैट द फेज शिफ्ट मेथड मीन्स there is a phase shift in the signal of 90 degree. Now in this method the either the upper side band or the lower side band gets to pass through while the other one gets blocked. As you can see, the block diagram is displayed on the screen. Here we are using phase shifters. Phase shifters means to provide 90-degree phase shift to the modulating signal and the carrier signal. Now we should know that here we are getting a lower sideband SSB signal, while we can also get an upper sideband SSB signal while adjusting the M1 and M2, which are the product modulators. Their rearrangements are necessary. Now here comes the advantages and disadvantages. The advantages of phase shift method is like it can generate the SSB signal of any frequency, of any. Like when we were talking about the filter method, it has some limitations because it was normal filtration. It has some limitations of frequency, while in phase shift method we don't have any limitation. Second, it can also use the low audio frequencies as modulating signal. Means again the same point that there doesn't need any specific frequencies for modulating a signal. And then the switching means like if you had to get a upper sideband or a lower sideband, the switching means either any one of them can be done easily. Then comes the drawback. The major drawback, there's only one drawback of it, that we need a perfect 90-degree shift of the modulating frequency, which is practically difficult. So at last, now we have the third method of SSB generation. The third method is also known as the Weaver technique, or the third method of the generation of SSB, that is single sideband suppressed carrier in amplitude modulation. So on your screen you can see a block diagram of the third method. It looks very complex, but it isn't. Here in a third method we have 4 balance modulator, 2 carrier signal generator, 2 audio low pass filter, and 2 90-degree phase shifter. Now in third method we got different phases. So in the first phase the modulating signal combines with the audio carrier. As you can see in the first half of the block diagram, the audio signal gets into a balanced modulator M1 and M2 with the carrier signals. But in one, the carrier signal is fed with 90-degree phase shift, while in other it isn't. So um, then it is passed through audio low pass filter. When we pass it to audio low pass filter, the upper sideband gets disappeared and only the lower sideband portion is left. Then it is again fed to balanced modulator for further refining, uh, which is connected to a carrier oscillator which provides again a carrier signal. Now this is also with 90-degree phase shift in M4 but not in M3. So here the vice versa projects go on. Now due to the phase shift, there is two condition which arises. In one, that the upper sideband has a phase shift of 90, while in the lower sideband it is of minus 90. While in the M41 case, the phase shift in upper sideband is 90-degree, while in lower sideband is 180-degree, which makes it totally out of phase. So therefore, one of the component gets cancelled out, and at last through the summing circuit, we get a specific either a upper sideband or a lower sideband as a result. So this is the third method from which we get the single sideband signals, and the advantages and disadvantages are here. First, the advantage of the third method is that it cross over the phase shift method. That is, its ability is more than the phase shift method to generate SSB at any frequency. Now here it is like written, it uses low audio frequency without the associated disadvantage of an AF required to operate over a large range of audio frequencies. So that's very clear. And then we have the disadvantages. First disadvantage is it is in direct competition with the filter method, but it is very complex. Direct competition and filter method because as if you have noticed, it goes same as the filter method. First we get the balance modulator and then we have to pass it through the band pass filter. So therefore these two are similar of kind, but the third method is a complex one because it has to go through different phases. And the second disadvantage is it is expensive and cannot be used commercially. So here next we come with the VSB. Now the question is, what is VSB? VSB is the vestigial sideband and it is a type of amplitude modulation technique. Here a portion of the reductant sidebands are removed to form a vestigial sideband signal. Therefore, so-called a vestige of a sideband remains. So now the question arises, what is VSB modulation and what is the need of VSB? So first of all, what is VSB modulation? Very easy. Vestigial sideband modulation or the VSB modulation is the process where a part of signal called a vestige is modulated along with one sideband. Now when it is sent one sideband, like it can be either the upper sideband or the lower sideband, irrespective of their position. It can be anything. Now here comes the need of VSB. Fine. Earlier we were using SSB and DSB SC in a very high quantity, but after the invention of or discovery of VSB, their use got deceased. It is because VSB is efficient in every of its way, and during SSB some a little of the signal data gets lost, while in DSP-SC double of it goes, which is a waste. In one we get the waste one, while in other some gets lost. So to overcome this problem, the discovery of VSB was made. Now here we get what is the need of VSB. Fine, but in VSB, when if we consider upper sideband, so a small portion of lower sideband is remain attached to it. Why? So as if there is any loss of the information, that it goes from the lower sideband portion, not from the upper sideband portion, because with that the upper sideband is considered as the useful information, right? So that's it. What is VSB? Then we see that along with the upper sideband, a part of lower sideband is also being transmitted in this technique, as I mentioned it earlier, that a guard band of very small width laid on either side of VSB in order to avoid the interfaces. The VSB modulation is mostly used in television transmission application, that it is mostly used in television transmissions, and now you can imagine that how good it is. The transmission bandwidth of VSB modulated wave will be the total of message bandwidth and the width of vestigial sideband. Two guard bands are laid on both the sides of that VSB signal so as to avoid the interface of the signal. Now here it is said that the guard bands, as you know what it is, it guards from shifting and other processes. As you know what does a guard mean. So two guard bands are laid on either side of the vestige. Vestige is the lower sideband portion in this condition. So that is to avoid the interface of the signals. Fine, that's easy to understand. Now at last we have the advantages and disadvantages of VSB. First advantage is it's highly efficient. True, though it is very highly efficient because it overcomes from every problem which other were facing, right? Then comes the reduction in bandwidth. Yeah, that's true, because it gets cut off. Then comes the filter design is easy as high accuracy is not needed. Yes, that's true, because now while we were filtering in other cases, for the upper and or the lower sideband, we need very accurate spectrum, while here we don't need it, because a little portion of lower sideband or either of upper sideband is needed to make it a vestige. The transmission of lower frequency component is possible without difficulties. Yeah, true. Has good phase characteristics. Good phase characteristics in a sense, it doesn't need that 90-degree phase shift or something like that. Now comes the disadvantages. Bandwidth when compared to SSB is greater. Yeah, obviously the bandwidth when compared to SSB is greater. This is because SSB just had either a upper sideband or a lower sideband. So if we consider the bandwidth to be 2, then in SSB the bandwidth would become 1, because it would be 1 for lower sideband and 1 for upper sideband, while in VSB it won't be 1, it would be 1 point something, less than 1.5 and 2, but it would be 1 point something, which makes it greater than SSB. And you know that if it gets greater, then the power consumption will increase a little, but that's considered as a disadvantage. And then is demodulation is complex. That's for sure, because more efficient you do as a modulation, more hard work you have to do in that. So at I would like to thank you, and apologies for any kind of like disturbance or something like that you are suffering during this presentation. And it is maybe due to the lack of many hardware devices. So but still, thank you, at last.